Have you ever written code that you thought would run smoothly, only to find out it's slower than expected? It's frustrating, right? If you've ever wondered why your recursive code is lagging behind its iterative counterpart, you're in the right place. Today, we're diving into the world of Python performance. I totally get it. You put in the effort to write a clean recursive function, only to see it perform worse than a simple loop. You're not alone in this confusion. Many developers face this issue, and it can be quite puzzling. Here's the specific situation we're looking at. A user wrote two functions to calculate the harmonic series, one recursively and one iteratively. They noticed that the recursive version was significantly slower, even though it seemed simpler. Sound familiar? Let's explore this together. So what could be causing this slowdown? The recursive function may look simpler, but it has a hidden cost. Each recursive call adds a new layer to the call stack, which can lead to increased overhead and slower performance, especially with large inputs. And don't go anywhere. At the end of this video, I'll share a crucial tip that can help you optimize your recursive functions for better performance. To understand why the recursive version of the harmonic series is slower, we first need to look at how recursion works. Each time the user calls the recursive function, it adds a new layer to the call stack. In the case of the recursive function, the user is making a call to itself for every single value of n down 1. This means that for large values of n, like 100 million, the function will make a massive number of calls. On the other hand, the iterative version calculates the harmonic series using a loop. This approach does not add layers to the call stack, making it much more efficient for large values of n. Additionally, the recursive function creates a list of values to sum, which requires more memory and processing time. This overhead can significantly slow down the execution compared to the iterative approach. In summary, while the recursive definition may seem simpler, it is less efficient for large inputs due to the overhead of function calls and memory usage. The user should consider using iterative solutions for performance-critical applications. Fun fact, did you know that recursion is often compared to a stack of pancakes? Each pancake represents a function call, and if you stack too many, it can topple over. Keep your stacks manageable. Now let's look at the answers provided by other users. A user suggests a fix for the recursive function. They point out that the original code mistakenly calls the iterative function instead of the recursive one. The corrected line should call hrec instead of h. Let's take a look at another answer from another user. This user explains that the speed difference between recursive and iterative functions in Python comes down to how the interpreter handles function calls. They point out that code executed directly in the interpreter is the fastest, while user-defined function calls are slower because the interpreter must manage a call stack for each function. They provide examples showing that a simple sum function is the fastest, while a recursive function is the slowest due to the overhead of multiple function calls. Here's the tip I promised. Always consider the depth of recursion and the size of your input. For large inputs, iterative solutions are often more efficient. Keep this in mind when designing your algorithms. And there you have it. Understanding the performance differences between recursive and iterative functions can save you a lot of time and frustration. If you found this video helpful, please subscribe for more coding tips and tricks.